Let us take another examination problem. So VTU question paper, June 2016. So this is a block friction problem with connected bodies. So one block is lying on the other block. So 200 kN block is at the bottom, that is block B, and block A is 100 kN. A force Q is applied at the corner point of this block A, top corner point, at an angle 20 degrees. And there are two contact surfaces here. So this contact surface between A and B has got the coefficient of friction value 0.4, and the contact surface between block B and the ground is 0.25. So the coefficient of friction is 0.25. They have given those values. Now the question here is, determine the force Q. We have to find this magnitude of Q to be applied for impending motion between A and B. So when this force is applied, definitely this block A tries to move in this direction. So in that case, what should be the value of that force Q to be applied? The second part is, will this force cause movement between B and the ground? So whether whatever force is applied Q at the top corner point of block A, whether that force will also make this block B to move on the ground. So this is the question. Now as I already told, this is the problem of block friction. So to analyze such problems, we have to draw the free body diagrams. So free body diagram of both the blocks we will write. Then we have to use the equations of equilibrium for concurrent force system. So there are two equations of equilibrium, sigma fx0 and sigma fy0, and then we have to solve for the unknowns. Now first let me write the free body diagram of block A. So we have to remove the contact points and we have to replace them by the respective reactions. So block A is here like this. This is block A. Weight of this block A is 100 kN. It acts vertically downwards. And it has given a force Q acting on block A at the top corner point at an angle 20 degrees. So we have to resolve this force into x and y components. So like this resolution is like this. This is Q cos 20 degree. This becomes Q sin 20 degrees. Now this is the contact surface between A and B. So since the force is applied in this direction, this block A tries to move in this direction towards right, in the direction of the force. So naturally friction force will develop in the opposite direction of motion at the contact point. So I will take the friction force like this. This friction force I call it as F1 because there are two contact points. So contact surfaces. I will take for one contact surface as F1, for the other one as F2. So F1 is the contact frictional force here, and N1 is the normal reaction. And you know that the relationship between frictional force and normal reaction is mu into N. F is equal to mu into N according to the law of friction. So it is mu times N1. So mu for this contact point surface is 0.4. So we can write F1 is equal to 0.4 times N1. This is the relation. Now this is the free body diagram of the block A. Now what we have to do here is we have to apply the equations of equilibrium for this. So as you know, we have two equations of equilibrium. I will consider positive x in the direction of motion and positive y upwards like this. Now let me write the equations of equilibrium, two equations of equilibrium for the block A. So sigma fx0, sign convention is forces acting towards right positive, left negative. So if you observe here, so this Q cos 20 is acting towards right, F1 is acting towards left. So only two forces are there. So to Q cos 20 is positive, minus F1 is equal to 0. So only two forces in x direction. One is acting towards right, another is acting towards left. So now I can write this as Q cos 20 minus 0.4 times N1 is equal to 0. So we cannot solve this because there are two unknowns. So this is equation 1 I call. Now the second equilibrium equation is sigma F1 is equal to 0. The sign convention for this is upward force positive, downward force negative. So if you observe this, Q sin 20 is downwards, so it is minus Q sin 20. So we have to take the component forces. Minus 100 kN weight is weight always acts vertically downwards. Then this N1 is positive plus N1 is equal to 0. Now if you simplify this, N1 will be Q sin 20 plus 100. So this is the second equation we got. So here you can observe that there are two equations and the two unknowns are there. We can easily solve that. So how to solve? Very simple. You have to substitute this value for this N1 in this equation. Then N1 is eliminated. You will be having a simple equation in Q and you can solve it. So substituting for N1 in equation 1. So it becomes Q cos 20 minus 0.4 times N1 is Q sin 20 plus 100. This is equal to 0. Now you can solve this because then only Q is the unknown. So what I do is Q I will take the common. Q into cos 20 minus 0.4 times sin 20 minus 100 into 0.4 is 40 is equal to 0. Or you can find out Q into, so this constant term, let me simplify. Cos 20 minus 0.4 times sin 20, which is 0.803. 0.803 is the constant term, is equal to 40. 40 if I bring to RHS, it becomes 2. So Q will be 40 divided by 0.803, which is 0.803, 49.81 kilonewton, because the weights are given in kilonewton, Q also will be in kilonewton. So this is the force that is required. Now once you get the value of Q, you can find out the value of N1 now. Substituting for Q in equation 2. So N1 will be Q is 49.81 into sin 20 plus 100. So now if you simplify this, 49.81 into sin 20 plus 100. So it is 117.04. 117.04 kilonewton. That is the kilonewton. So normal reaction at the contact surface between A and B, you are getting 117.04. So later on you can find out the frictional force also. F1 is 0.4 times N1. Already you know that. So that is 0.4 into 117.04. So you are going to get the value as 46.81. 46.81 kilonewton. 46.81 kilonewton. Now here we got the value of Q now. The first part of the problem is over up to this. So whatever value of force required to move the block A on B, we have got it. And also we got the normal reaction and the frictional force. Now, one thing you have to understand here is, since block A is resting on block B, so you have to observe here the concept, because one block is resting on another block. This is block A, this is block B. What happens here at this contact surface between A and B, since the block A is moving like this due to the application of force Q, frictional force will develop like this. That's what I have shown here. So that F1 is for this block A. So at this junction, you have frictional force acting on block B also, but in the opposite direction. So this concept is very, very important. Like this, because at the junction also it should be in equilibrium. This F1 is the friction on block B. This F1 is the friction on block B. Now, similar to this, we have the normal reaction also. Normal reaction for this block A, N1 will be acting like this. For this block B, N1 will be acting like this. Please note that they are collinear. So this is how we have to take. So that means I have considered the equilibrium of the contact surface itself. That is the junction between A and B. That means whatever value of F1 you have got here, same value of F1 will be there for this also. So now what I will do here is, I will try to write the free body diagram of block B now. FBD of block B. Now I have to take only this one now. So be careful here for writing the weight of this block B is 200 kN, that is given. It is acting vertically downwards. Now be careful that this F1 force, I have to take this one for block B. So F1 is acting like this. So this F1 force already we have got it as 46.81 Newton. This value we have to take. A normal reaction for block B is this one. So normal reaction is acting like this, that is N1. So N1 value we got it as 117.04 Newton. So write down that. Now, if this block B has a friction force like this, it should move in this direction. Direction of motion of block B will be like this. Actually, and there will be one more friction force here also, that is F2, that is between the block B and the ground. So F2. So this F2 and N2, they are the friction forces in normal reactions between the block B and the ground. Now this F2 is once again mu times N2. Mu for this contact surface is given as 0.25. So therefore F2 is 0.25 times N2. This is what we have to write. Now this is the free body diagram of block B now. So this is free body diagram of block B. So we have F1, F2 to frictional forces, N1, N2 to normal reactions, and the weight of the block 200 kN. Now we have to analyze this diagram by applying the equations of equilibrium once again. So I will take x direction like this, y direction like this, or we can take x direction like this, because normally what we do is along the direction of motion we take positive x axis, opposite direction is negative x axis. Now since direction of motion of B is like this, so this is decided based on this friction force value. And now if you apply this equation, sigma fx0 for this, let me write sigma fx is equal to 0. Only the difference is direction of motion is this direction, therefore towards left is positive, right is negative now. So now if you use that concept here, you can see here F1 is negative, F2 is also negative. So the thing is here, F1, F2 both are negative, and this N2 value, of course this N2 value will be equal to, N2 is equal to N1 plus 200. Is it not? This is upwards, this you can read by using this sigma F1 is equal to 0 equation. By considering an upward force positive, downward force negative, you will get this. So that means this is N1 is 117.04 plus 200 means it is 317.04 newtons kilonewtons. So this is the value of N2. Then when N2 value is that much, F2 will be 0.25 times N2, 0.25 times N2, which is I can take it as 0.25 into 317.04, 79.26. 79.26 kilonewton. Now once you get the value of f2, then you can observe here that minus f1 minus f2 should be equal to 0 if you get, is it not? Because there is no other force acting on the block B, but what you are getting here, since your value of f2 and f3, they are like this. So f2 you will get f minus 46.81 minus 79.26 should be 0, which is not correct. Not correct. So what is the meaning of this? The meaning of this is, since the equilibrium equation is not satisfied in the x direction, so the thing what we are asked is, will this force cause movement between B and the ground? No, there is no movement. Because the equilibrium equation is not satisfied, the body remains at rest only. So equilibrium, I write equilibrium equation is not satisfied. Is not satisfied. Therefore, there is no movement of block B. There is no movement of block B on the ground. You can see here, so that sigma x is equal to 0 is not at all satisfied, because the values of f1 and f2 they are different, and it is not equal to 0 in the RHS. So this is how we have to analyze the block friction problem.